Looking at transformations of y equals x squared. Every type of quadratic we've been using has been a transformation of the original quadratic function, which is x squared. A transformation is simply a changing of the graph. So we're changing the graph by either stretching or compressing it, moving it vertically or horizontally, or reflecting it on the x or y axis. Looking at our first one here, vertical stretch. A vertical stretch is a transformation where the graph is expanded vertically, resulting in a narrow graph. So that's like if we have an A where it's making it larger. We're bringing it and making it go up quicker. A vertical compression is the other way. This is where we're taking a graph and we're compressing it vertically, resulting in a graph that's wider and fatter at the base. The third thing that we can do to a graph is reflecting it. What that means is we're making a mirror image with respect to its line. What it means, we're flipping it upside down. So when we're reflecting it in the x-axis, what we're doing is flipping it. So that's when our A is negative. The next thing that we're looking at is a vertical translation. What a vertical translation is when we move the graph up and down. So either pushing it up above the x-axis or down below the x-axis. The next one we have, which is our fifth type of transformation, is a horizontal translation. That's when we shift the graph either left or right. So let's look at some examples here. So a vertical stretch, which is the important part here, a vertical stretch is when we are having a factor of A. A is the important part. This is what we're changing. And A is larger than 1. A vertical compression happens when we have an A value that is smaller than 1 but greater than 0. So that would be like if we had 0.5 on the graph. So let's go check out an example by graphing these into decimals. So let's start off with our nice x squared. This is a normal x squared. Now if we have 2x squared, what you're going to notice is that in this blue, it's stretching, it's getting taller quicker. Now if we had a compression, so we're going between the 0 and the 1, it gets a little bit shorter and wider at the base. You can see if you go in, you can see that a lot more clearly. The red is the original x squared. Our stretch, our vertical stretch is in the blue, and our compression's in the green. So how do we describe this? If we have the graph of y equals 2x squared, it is a vertical stretch. So these are the words that we're going to use. A vertical stretch by a factor of 2. We use the number in front of the x squared. That is our A value. So if we have a graph of half x squared, this is considered a vertical compression because we're compressing the graph. So it's a vertical compression of the graph y equals x squared by a factor of 1/2. And we can see that it's right in front of here. that 1/2 is the compression. Vertical compressions and stretches are the only types of transformations that actually change the shape of the graph. So that's really important. So these are the only shape transformation. So this only changes the shape of the graph. This doesn't move it left or right or up or down. Now the next types of transformations do move the graph around. So if we're looking at a reflection in the x-axis, this is when we flip it. So this is when our a value is less than 0. Oh, I wrote this wrong down. Is less than 0, but not equal to 0. Because remember, we can't have a quadratic if it's not equal to 0. So what I want to show you on Desmos is a couple of different ones. So we still have up right now the x squared. So I'm just going to keep x squared up. This is going up, nice, neat. Now, what if I was to graph negative x squared? What you're going to notice is it's the exact same graph, but it's flipped down. If we did negative 2x squared, it's flipped down. Let's put back up the back up the 2x squared. That's the same graph. This is negative 2x. It's just flipped upside down. That's the main difference between the two. So again, if we're going to write out the descriptions, the graph of negative x squared is a reflection of x squared across the x-axis, because where it's flipping is on the x-axis. We're flipping it upside down. So the graph of y equals negative 2x squared is two things. The first thing is it's a reflection of y equals x squared across the x-axis. So that's its first transformation. Its second transformation is a vertical stretch of y equals x squared by a factor of 2. Just so you guys can show, this stretch is the 2. This reflection is caused by this negative. So these are some of the different ways we're going to change the shape. Translations. You've probably heard of translations before, where you take something's original shape and you move it to a different spot. Looking at this example here, we have a triangle ABC, and we have it being translated over to a different position. It's being moved 8 units to the right. 1, 2, 3, 4, 5, 6, 7, 8. And then it gets moved 8 units down. See, 1, 2, 3, 4, 5, 6, 7, 8 to its new spot. We can do these with this type of movement, this type of translation with quadratics as well. When you are looking at the vertex form, I gave you guys a hint where the K here was a vertical translation. So the K moves the vertex either up or down. So let's go and look at on Desmos these two examples. So we have our normal lovely x squared, nice happy, nothing's being messed with it. Now we're going to mess with it. We're going to have x to the power of 2, and we're going to now add 2 to that graph. What that does is it moves this graph up 2 units. And if you guys can guess, if I was to do x squared and I subtracted some units, I'm going to move the vertex down. So I'm going to move it down by 4. So the original origin point or vertex of x squared is at 0, 0. When I take away 4, the new vertex is at -4. When I added 2, the new vertex was at 0 and 2. This is how we're moving it around. So in words, compared to y equals x squared, the graph y equals x squared plus 2 is vertically translated 2 units up. So vertically translated 2 units up. And y equals x squared minus 4 is a vertical translation 4 units down. So if we can translate something up and down, we can also translate something to the left and to the right. This is a horizontal translation, and this is represented by H. This lovely guy moves the graph either left or right. But let's see which way is what. So we got our lovely x squared again, nice, unadulterated. We're going to mess with it. So bracket x, I'm going to move it some direction. I'm going to move it by -2. Now, -2, what that means is I'm going to be moving it to the right. So if you see a negative x minus something, we're moving that entire graph to the right. In this case, we're moving it 2 units to the right. Now, if subtracting it from the x moves it to the right, when we add to it, it's going to move it to the left. So x plus 4, bracket squared, that moves the entire vertex 4 units to the left. So let's write this guy out. Compared to y equals x squared, the graph y equals x minus 2 squared is a horizontal translation. Two units right. It moves the graph to the right. Now, x plus 4 squared is a horizontal translation to the left by 4 units. Okay, let's look at this guy. Describe the transformation that would apply to the graph y equals x squared to create the graph of y equals 2 bracket x minus 4 squared plus 3. So let's start with looking at the information. So we're going to start with this one right here. First part, -2, the positive 2. This is a transformation of the parabola. So the parabola is vertically stretched by a factor of 2. So that's the first part. And the next part, what we're going to look at is right here, that horizontal translation. I'll write that in blue. So the parabola is horizontally translated for units. Now, if we're subtracting in the bracket, that means we're going to the right. And the last option, last part that's happening to this is this +3. That is our vertical translation. So the parabola is vertically translated 3 units up. So when we're graphing this, we want to plot our vertex. And our vertex is 4 and 3. Now remember, when we're looking at our vertex, we look at our h value and take the opposite sign, so that's +4, and we just take our k. So that's our vertex. So we're going to plot our vertex on this guy at 4 and 3. X equals 4. And put this right here. Now this is something new that we haven't really discussed, is how to graph it. We have something called the step, quadratic steps. We're going to use steps. Quadratic steps are related to the a value. So every quadratic will follow the a plus, for the first one, you move over just the a value. When you go over 1, you go up 2. Now the next time when you move it is going to be 3a. And the next one's 5a. Every time you move from the vertex. The a in this case literally means the a value in front of our graph, which happens to be 2. So if we're looking at this one, it would be saying 2, because we replaced the a with what our a is, 2. And then moving from the next point, we would have 3 bracket 2, which goes to 6. Same way here, we'd have 5 bracket 2, which goes to 10. And how we plot this is we go over 1, up 2. Just get that better. Go over 1, up 2. Go over 1, up 2. Now with the next one, we're going to go over 1 from the last point, and we're going up 6. So 1, 2, 3, 4, 5, 6. And we do the same thing on the other side. Over 1, up 1, 2, 3, 4, 5, 6. And that's how you use the step method to go up and down. And we're going to connect the dots. As best as your ability, again, I would never dock your marks for not being perfect because quadratics are very hard to draw, unlike linear where you can just take a ruler and plot it in. And that is how we plot these guys. Let's go to another example here. We want to describe the transformations that would apply to the graph of y equals 2x to create the graph of negative 1/2 bracket x plus 6 squared minus 5. So first one we're going to look at and deal with is the negative. So that's our first thing we're going to deal with. So this means, since we see a negative, the parabola is reflected. in the x-axis. Next thing we're going to deal with is the 1/2. Remember, the half means that it is compressed. So the parabola is vertically compressed by a factor of 1/2. Next thing we're going to look at is the +6. This is our horizontal translation. So the parabola is horizontally translated 6 units left. And last but not least, what we need to look at is the -5. So the parabola is vertically translated now 5 units down. So this gives us a vertex of -6 and -5. And if we're going to use the step system, remember the step system is A, 2A, sorry, 3A, which means I made a mistake over here, guys. So let me just go and remind you. Yep, 3A, perfect, we're good. Didn't make a mistake over there, just made a mistake here. Got 5A, and we're going to now look at the step system. So A, our A is -0, -1/2. So if it's -1/2, that means we're going down by -0.5. Looking at the next one, 3 times A, and our A is -0.5. So 3 times -0.5 gives us -1.5. And for 5, we're going down -2.5. These aren't going to be perfect for when we're graphing, but we will try our best with these. So we're going to be starting out at -6 and -5. When we go over 1, we're going to drop just by a half. And now when we go over 1, we're going to drop 1.5. Again, as we go out again, we're going to drop 2.5. And then we connect the dots as best as we can, remembering that quadratics are hard to draw. So be kind to yourself if it's a little wonky. And that is our graph. So what you guys have to do now is some homework. Here's our summary that will tell you how to say everything. Write it down. More in-class practice. And then there's the assigned work. The answers are all posted here. These ones are on the next page, as you can see. This is a perfectly acceptable way of writing it. You don't always have to write out the full sentences. That's just really good practice, okay? And that is today's lesson.